Good day viewers, and you are welcome to MLT channels. Today's subject matter is chemistry, and the topic of our discussion is isomerism in alkanes. You are all welcome on board. Alright learners, without wasting much time, let's quickly dive into details. Today we are looking at isomerism in alkanes. The first member of alkanes that exhibit isomerism is actually butane, with the molecular formula of C4H10. Butane has two isomers, which are N-butane and isobutane. So now the next task is to get the structural formula of the isomers of butane. So starting from the first one, which is N-butane. So in order to draw the structural formula, we need the molecular formula, which is C4H10. So the first thing is to draw the 4 linear carbon chain, which are, it is made up of 4 linear carbon chains in the N-butane. This is possible because of catenation, which is the ability of carbon to bond with itself. Carbon has the valence electron of 4. So if two carbons bond, they achieve stability by forming octets. So that makes the 4 carbon atoms to form a bond on a linear chain. Then they are surrounded by 10 hydrogen atoms. We need to make some analysis here, and those analyses will involve which carbons are the primary, the secondary, the tertiary, and the quaternary, because in our alkenes the carbon also have their respective types. So now after we have drawn our N-butane, let's number our carbon atoms. We start the numbering from the first one. Here is 1, here is 2, here is 3, and there is 4, which we have gotten from our formula C4H10. Then we should count the hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have exhausted our formula, molecular formula, which is C4H10. Now the next thing we want to identify here is that which ones are the primary carbon atoms, which one is the secondary, and we even have the tertiary here. For instance, this first carbon atom, those carbon atoms are the terminals. Carbon atom with 1 and 4 are primary carbon atoms. Where are they primary? Because they are bonded by 3 hydrogen atoms. So whenever a carbon atom is bonded by 3 hydrogen atoms, we call such carbon atom primary carbon atom. So the primary carbon atom is always bonded by 3 hydrogen atom and just only a single carbon atom. These two are the terminals. This carbon atom, this locant 1 is bonded with only one carbon atom, which is that of locant 2. So this first carbon atom is primary. The same thing applicable to this fourth carbon atom. Is also bonded with only one carbon atom at 3. So it's also a primary. Why the second and the third carbon atom are secondary carbon atoms? Why? Because the second carbon atom is bonded by 2 carbon atoms. It's bonded by carbon atom 1 and carbon atom 3. And that makes this second carbon atom to be secondary. Also, this third carbon atom is also secondary because it is bonded by 2 carbon atoms, which are carbon atom 4 and carbon atom 2. So in a nutshell, this is the N-butane, and that is the first isomer of butane. Now going to the second isomer of butane. In the second isomer, we have to reduce our linear carbon atom into 3 so that we can have a branch chain. Okay, and this one is isobutane. Both N-butane and isobutane, they share the same molecular formula because they are isomers. The only difference between them is their structural formula. Isobutane also has the molecular formula of C4H10, and we have 1, 2, 3. So we have 3 linear carbon atoms. Then we have a branch. Then this branch cannot be at the terminals. The rule says that you cannot have the branch at the terminal carbon atom. So since we just have only 3, that means we have it at the middle. So we have exhausted our carbon atoms. The next thing is to fill our hydrogen atoms. So in order to name this, we consider the longest carbon chain, that will be the parent's name. Then we start the numbering from the closest to the branch chain. Since from both left and right they are the same point to the branch chain, so we can actually start our numbering from it. So here will be 1, here is 2, and here is 3. And the total number of carbon atoms we should have supposed to be 4. 1, 2, 3, 4. So we've actually exhausted our carbon atoms. Then the hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I think one is missing here. Okay, so with that we've exhausted our hydrogen atoms as well. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then how do we now name this? To name this, we first consider the branch chain. We have a branch here. We have a branch chain here. So on what carbon atom do we have the branch chain? We have the branch chain on the second carbon atom. So the name will now be, since it's on the second carbon atom, it will be 2. because you have the branch on the second carbon atom. Then where we have the branch, what functional group is this? This is alkyl, and precisely this is methyl CH3. So that will be 2-methyl then 2-methyl what? Now we now count the total number of carbon atoms we have at the longest chain, which is the parent name. 1 to 3 is 3, and the alkane with 3 carbon atom is actually propane. So the name will be, the IUPAC name will be 2-methyl propane. That's the second isomer of butane, 2-methyl propane, which is conventional name is called isobutane. Now, other things we need to analyze here is that this first carbon atom is primary carbon atom. Why? Because it is bonded by just one carbon atom. Why this second carbon atom? This one is tertiary carbon atom. Why is it tertiary? Because it is bonded by 3 carbon atoms. This is one from the left, this is another one from the right, and we also have one from the bottom. So that second carbon atom is actually a tertiary carbon atom. While the third one is also primary because it's also only bonded by 2 carbon atoms. Now all these having been said, let's now look at other ways of writing the formula, the structural formula of this. This is the common structural formula. Common structural formula. We can also have other types like the staggered, the condensed, and the zigzag. To write the staggered, we need to take note of that our alkane is always starting with, at the terminals, it always have the alkyl group at the terminals. So here now we could divide this into section. This should be the first section, and this is CH3. Then this is the second section, CH2. Apart from the terminal carbon, all those ones at the middle always have 2 hydrogen atom bonded with them, or the secondary carbon atom. But in some case, like in this case now, the hydrogen atom has been substituted by an alkyl group. So we're still coming into that. Then the third section is this, where we have CH2, and the final section is this, which is the fourth section, which is also CH3. This is also another structural formula of butane, and this is called the staggered structural formula. And this staggered structural formula can also be written in form of condensed. If you want to write it in form of condensed, we also pick it, we reduce the section now. Here will now be the first section, and that's our CH3. Here will be the second section, that is C2H4. So that's C2H4 now, and here will be the last section. So this C2H4, we can write it as CH2. Then how many of it do we have? we have two of it. That implies that we introduce a bracket 2, then CH3. Butane can also be written in this structural formula, and this is called the condensed structural formula. And the final formula way we can write this is to write it in form of zigzag. And if you write that in zigzag form, since we have exhausted the bottom, let's use the top here. If you write that in zigzag form, it will be something like this. CH2 is 2, CH2, then also CH2, then at the top here we have CH3, then at the bottom here we also have CH3. And this is the zigzag structural formula. So these are different ways in which normal butane structural formula can be written. We can write it in this first form, which is in form of a straight linear carbon chain, and we call that N-butane, which is a common structural formula of butane. Another method is by writing it in section, which gives us the staggered structural formula. You can write it in section, which gives us the structural formula. Then we can also write it in condensed, and we can also write it in zigzag as well. Then for the isobutane now, let's analyze this also. In this, you can also break it into section. This is the first section, and this is CH3. Now the second section is here, and convince yourself that this is supposed to be in form of CH2, but the hydrogen atom has been substituted by alkyl group, which is methyl, because of the branch chain. So this will now be in form of CH. The second hydrogen atom is missing, so we introduce a bracket. It has been replaced by an alkyl group as the branching chain, which is CH3. Then here is the final section, which is also CH3. And this is the staggered structural formula of isobutane or 2-methylpropane. And we can also write this in condensed. To write it in condensed form, we have CH3, then CH. Then if you look at on this CH, we have surrounded by 2 CH3. So we have CH3 into bracket 2, and this is the condensed structural formula of isobutane or 2-methylpropane. Alright, I hope this is clear enough. If this is clear enough, let's now move to the next slide. Alright, learners, on this slide, we want to assess what you have learned so far, and we have a quiz now. So, question 1 on the quiz, we have, what is the correct IUPAC name for the structure? What is the correct IUPAC name for the structure? Look at the structure: C3, C2, CH, C3, C2, C3. So what is the correct IUPAC name? Is it option A, 2-methylpentene, option B, 3-methylpentene, option C, 2-methylbutane, or option D, 3-methylhexene? Let's now analyze this quickly. We are using this staggered structural formula to draw a common structural formula, because if you are not so very vast in organic chemistry, it may be very difficult for you to name this with this staggered formula. So to make it simpler or easier, let's write it in common structural formula. So in doing that, our CH3, we start from CH3. So, okay, permit me. So we start from our CH3 at the extreme left side. We have CH3. Then we have CH2. And then we have CH. We are supposed to have CH2. The moment H is missing here, the second H has been substituted by an alkyl group. That means we are going to have a branch chain here. So, and the second hydrogen atom has now been substituted by methyl. Then we continue our parent carbon atom. So we have CH2. Then finally we have CH3. Now let's fill our hydrogen atoms. So to name this, we first consider our parent carbon atoms. Let's count our parent carbon atom, which is the longest linear chain. We have one. Okay, sorry, I'm not supposed to start numbering now. I'm not supposed to start numbering. We have to consider the branch chain. We have to consider the branch chain. The closest carbon atom to the branch chain, that's where we start our naming from. And if we should check from left, we have 1, 2, 3. We have 3 carbon atoms before the branch chain. Also from right, we have 1, 2, 3. We also have 3 carbon atoms on the branch chain. That implies that we can actually start the naming from anywhere we like. If the numbering either left or right. So let's start from left. 1, 2, 3, 4, 5. We see that the branch chain actually fall on the third carbon atom rather. So that implies that our name will start from 3, then 3 what? On what's it called? On the branch chain, the branch that is formed on this third carbon atom is C3, and C3 is actually methyl. So that is 3-methyl. Then methyl what? To know methyl what it is, we have to count the number of carbon atoms we have in the longest linear chain, which we now refer to the parent name. And if you count, we have 1, 2, 3, 4, 5. So it's 5. And the alkane with 5 carbon atom is known as pentane. So the name will be 3-methyl-pentane. And that is option B. That implies that option B is the correct answer here. If this is clear to us, let's move to this second question on the quiz. Alright, learners, on to the second quiz question, question 2. Which of the following is the structural formula of 2,2-dimethylbutane? Is it option A? Is it option B? Is it option C? Or is it option D? We don't know yet until we have analyzed that 2,2-dimethylbutane. In order to draw the structure, the first thing we need to consider is the parent carbon atom, which is butane. And we know butane has 4 carbon atoms. So the first thing is to draw our 4 linear carbon atoms. And we have done that. Now the next thing is to consider the functional group, which is the 2,2-dimethyl. So for the 2,2-dimethyl, if you like, we can start the count from the left, 1, 2, and if you like, you can start the count from the right, 1, 2, anyone that is convenient for us. But I prefer that we should start it from the left. So 1, 2, we count 1, 2. So at that 1, 2, we are going to have a branch, that is 2, the first 2. Then for the second 2, we still have another branch on the second carbon atom because it's 2, 2. So we have a branch here. We have CH3 here, which is our methyl. We should have been familiar with that now. Then this also will be CH3, which is also our methyl. That is 2,2-dimethyl. Then the next thing is to fill our hydrogen atoms. Then let's now number. Let's do our numbering. For our numbering, we consider here the second carbon atom where we have the branch. So this will be 1, 2, 3, 4. So now this should be 1, 2. We have a branch. Also 1, 2. We have another branch. So this is actually now then the parent, to know the name 1, 2, 3, 4. That is butane. So this is 1, 2, 2, 1, 2, 2, 2 dimethyl because it's 2 methyl. That's why it's dimethyl 1, 3, 4 butane. But if you look at the options now, there is none of the option that looks like this common structural atom. That is why we need to understand both the staggered and the condensed. That's why we need to understand both the staggered and the condensed. Now we now have to write this either in staggered or condensed form for us to be able to get the answer. And don't forget, we have to section it. So this first section, that is CH3. Then also Here is also another section. The two hydrogen atoms that are supposed to be bonded with this carbon are now replaced by alkyl. So we have just one carbon atom. Then we're going to introduce a bracket to indicate a branch chain, and the branch are 2 methyl. So that will be methyl into bracket 2. Then the third section is our normal CH2, which are expected to have for secondary carbon atoms, a carbon atom that is bonded by 2 carbons. Then the fourth section is our CH3. Oh, there's a mistake. The second to the last section is CH2, not 3. Now let's now compare our answer. CH3, CH3 into bracket 2, CH2, CH3. So out of all these options A to D, the one that is similar to what we have done is option B. And I hope this is clear enough too. If that is clear, let's quickly move to the last question on the quiz. Alright learners, we have the final question on the quiz. And question 3 says, identify the correct name for this structure. Look at our structure. CH3CH into bracket CH3CH into bracket CH3CH. Is the correct name A 2,3-dimethylbutane, B 2,2-dimethylbutane, C 3,3-dimethylbutane, or D 2,3-dimethylpentane? In order to know this, we just have to draw the normal structural formula for this staggered structure. And in order to do that, we start from A, CH3. So normally our CH3, we have a primary carbon atom which is bonded or surrounded by 3 hydrogen atoms. Then we have CH. The moment we have just one H on secondary carbon atom, we know that there must be a branch because the second hydrogen has been substituted by methyl. So this one will give us a branch chain, which is CH3. Then also we have CH. The second hydrogen atom here has also been substituted by an alkyl group, which is methyl. Then we also have CH3 at the terminal, which is normal. So the next thing is, let's fill all our hydrogen atoms. Now, this is still not similar to what we are looking for. So we have to write this now in, what's it called? We have to name it. To name, we consider the closest carbon atom to the branch. If we count from left, we have 1, 2. If we count from right, we still have 1, 2. So we can actually start the counting from anywhere we like. But I always prefer to start from the left. This is 1, 2, 3, 4. Even if you count from left, this will still be 1, 2, 3, 4. It's still the same thing. So what will now be the name? The name will now be 1, 2. 1, 2. We have a branch here, that is 2 methyl. we have a branch here, that is 2-methyl. Also 1, 2, 3. We also have another branch here which is also methyl. So we have 2, 3 methyl. So the name will be 2, 3, and the 2, 3 are methyl. 2, 3 methyl. Then methyl what? We have to get the parent name by counting the longest carbon chain. And how many carbon chain do we have as the parent name? 1, 2, 3, 4. That is 4. And the alkene member with 4 carbon atom is actually butane. So the name will be 2,3-dimethyl. Sorry, that won't be methyl. That will be di, because it's 2-methyl now. 2,3-dimethyl butane. Then do we have that in the option? Yes, that is option A. Alright, we are done with the quiz. Now let's move to the next slide. Okay, on this slide we are supposed to talk about isomerism of pentane, but because of time we have to suspend that to the next class. But have it at the back of your mind that pentane has 3 isomers, and the 3 isomers of pentane are, we have the N-pentane, which is here, the normal pentane. We have the isopentane, which is known as, this is 2-methyl butane. It's same as isopentane, because if you should count, we have 1, 2. After the second carbon atom, we have a branch chain, and the parent 1, 2, 3, 4. This is what's it called? That's butane. So the name of this is 2-methyl butane. And the last one, neopentane. This neopentane, we have 1, 2, there's a branch to the top, 1, 2, there's a branch to the bottom. So that is 2, 2, 2, 2 dimethyl. Then the parent is 3 carbon, that is 2, 2 dimethyl propane. So by the special grace of God, in the next class we shall analyze the isomerism of pentane. Alright, now to assess what we've been learning so far, we have an evaluation, and under the evaluation we have the first question that reads, state the type of isomerism shown by alkanes. 2. What is the minimum number of carbon atoms required in an alkane to exhibit isomerism? 3. How many structural formulas does hexane have? 4. What is the main difference between N-butane and isobutane? And finally, state 2 uses of alkane. And alright learners, that will be all for today's class. For more videos, you can visit our MLT channels at TikTok, and our handle is at Oladepo61. Also, you can watch our videos on YouTube, and our handle is at Oladepo2262. You can book me for home and private tuition, and my WhatsApp number is 080-670-76871, or you can reach me via mail, and my email address is oladepo.on@gmail.com. Before you go, don't forget that success is not final, failure is not fatal. It is the courage to continue that counts. Until I come your way again, thank you for watching, and bye for now.